Have you ever, like, paced the room or tacked your foot just to remember the name of an actor in a movie? You are basically stalling, right? Just to buy your brain some time.
Well, it turns out AI actually does the same thing.
Yeah, so welcome to this deep dive into a Google research paper titled Thinking to Recall. We are unpacking this really weird phenomenon of why large language models need to reason just to answer simple trivia questions.
Right, because we generally expect an AI to use a step-by-step reasoning phase for, complex math.
Or like tough logic puzzles.
Yeah. The real mystery is why it needs that computational runway for simple single-hop facts. The researchers found that across models like Gemini 2.5 and Qwen 332B, enabling a reasoning phase expands what the paper calls parametric knowledge recall.
Wait, let us break that down a bit. Parametric knowledge recall sounds super dense. Are we just talking about the facts permanently baked into the neural network from its initial training?
Yes, the static facts hidden in its weights. The reasoning phase basically unlocks correct, factual answers that the model simply could not reach otherwise.
But, I mean, if it already knows the answer, why does it need to talk to itself first to find it? That feels more like magic than computer science.
It really comes down to the physical mechanics of how these models process information. The first mechanism they identified is the computational buffer effect.
Okay, so how does that play out in a test?
Well, they ran a controlled experiment using a highly specific trivia question. They asked what year Mary Ingle Pennington was inducted into the National Inventors Hall of Fame.
That is definitely a deep cut.
Oh, very. And initially, the AI totally failed to produce the year.
So they let it, like, think out loud to see if it could find the right date.
They did, but with a pretty clever twist.
Yeah.
They replaced the generated reasoning text with a meaningless dummy string.
Wait, what does that mean?
They forced the AI to just repeat the words. Let me think over and over before answering.
Oh, wow.
Yeah, and just forcing those extra computational steps allowed the AI to correctly retrieve her induction year, which is 2018.
That is wild. Stalling with, obviously gives our human brains extra processing cycles. But how does typing, let me give a computer more processing power? It is not adding any new information.
Because every single token or word the model generates forces it to run another full pass through its entire neural network.
Oh, I see. So generating empty text acts as a buffer.
Right. It effectively gives the system more time and compute power to search its hidden layers for that deeply buried date.
The stalling buys time to search the network, but surely the actual words the AI generates matter too in a normal scenario. I mean, it is not just saying, let me think out in the
The
wild.
words matter immensely. And this brings us to the second mechanism, factual priming.
Let us get into that one.
In another test case, the AI needed to identify the 10th king of Nepal. During its thinking phase, the reasoning trace sequentially listed out the first 9 kings in order.
Oh, and the paper calls this generative self-retrieval, right? By generating those related facts, it builds a semantic bridge to the correct answer.
Yes, the previous 9 kings act as context clues to trigger the 10th. But that generative self-retrieval introduces a massive trap.
What kind of trap?
If the AI hallucinates an intermediate fact while thinking, it drastically increases the likelihood of a hallucinated final answer.
So if it incorrectly names, say, the 8th king, it steers the neural network down the wrong mathematical path.
The weights just shift toward that fabricated context.
It builds a contextual bridge to reach the memory, but if it fabricates a single plank along the way, the whole final answer just collapses.
And the semantic bridge only holds weight if every plank is factually sound. In their large-scale audit, the researchers found that reasoning traces with hallucinated intermediate facts were systematically less likely to produce correct final answers.
So for you listening, large language models really have 2 distinct ways out of this memory block during their reasoning phase. They use compute buffers to stall for processing time.
And they use factual semantic bridges to lay down related truths to reach the final answer.
Which leaves us with a fascinating parallel.
Yeah, if a highly advanced AI relies on the sequential generation of words to unlock its own stored knowledge, maybe human memory recall is equally dependent on the physical act of articulating our thoughts out loud.
Maybe that pacing and foot tapping we do is not just nervous energy. Maybe, like the AI saying, let me think, we're just running our own biological compute buffer to bridge the gap to that forgotten movie title. Something for you to ponder until our next deep dive.